Imagine a hospital rolls out this, like, multi-million-dollar artificial intelligence system.
Hmm.
And the whole goal is to flag the sickest patients so they can get extra medical care.
Right, a massive investment.
Exactly. But almost immediately, the system just starts systematically denying care to the exact people who need it most.
Oh, wow.
Yeah. Or, picture a massive automated welfare system. It looks at the really nuanced, chaotic file of someone who's, say, fleeing domestic violence, and it just registers a system processing error and denies them their benefits.
Which is devastating.
It really is.
Yeah.
And I mean, every single day, you and I are told that AI is going to make our businesses, our hospitals, and our courts smarter, faster, and just, well, infinitely more rational.
Yeah, we've all heard the pitch, right? Machines don't get tired.
Right. They don't have bad days. They aren't burdened by all our messy human biases. So, naturally, they must make better decisions.
It is an incredibly compelling narrative. I mean,
Right.
that narrative alone is driving billions of dollars in organizational investment across the globe right now.
Oh, totally.
The assumption is just, if we can process enough data fast enough, we can basically engineer our way out of human error entirely.
But today, we are taking a really hard look at a piece of research that completely flips that assumption on its head.
Yeah, it really does.
We are diving into a fascinating and highly counterintuitive paper by Dr. Jonathan H. Westover. It's called The Rationality Illusion.
It's a great read.
And the mission of this deep dive is to really uncover why treating artificial intelligence as a substitute for human judgment is actually making organizations, well, significantly less intelligent.
Right.
Okay, let's unpack this. To really wrap our heads around what's happening, I want you to think about AI like a highly efficient line cook in a busy kitchen.
Okay, I like this analogy.
Right, so this cook is mathematically perfect at chopping like 1,000 onions in record time.
Super.
Exactly. But you would never want that same line cook deciding the entire menu for a five-star restaurant based solely on how fast they can chop the ingredients.
Yeah. That framing gets right to the heart of the issue, honestly. And, just to be clear right up front, the research we are looking at today, it is not some anti-technology manifesto.
Right, we're not smashing the computers.
Exactly. The author isn't suggesting we go back to pen and paper or just abandon computation altogether. What he is pointing out is a fundamental category error.
A category error.
Yeah, one that organizations are making across the board right now. I mean, they are mistaking optimization for judgment.
Right.
They're confusing massive data processing with actual genuine understanding, and they're treating consistency as if it were the same thing as wisdom.
So before we look at the mechanical breakdown of, how AI actually fails in practice, we first need to figure out why we are so eager to hand over the reins in the first place.
Why we trust it so much.
Exactly. Why is our standard definition of rational decision-making so flawed? The paper explores something it calls the seductive syllogism.
Yeah, the seductive syllogism. It's essentially this logical trap that leadership teams fall into. The first premise is something we all instinctively agree with, right? Humans are notoriously biased, we process information slowly, and our application of rules is painfully inconsistent.
So true. I mean, we're a mess.
We are. And then the second premise is that algorithms are perfectly consistent. They analyze vast amounts of data instantly, and they never get fatigued.
Right, so the conclusion seems unavoidable.
Exactly.
What?
Therefore, algorithms must make more rational decisions.
I mean, it sounds bulletproof on the surface. If our bad decisions stem from our cognitive limits, then a machine with functionally zero cognitive limits should be the ultimate rational actor.
It sounds bulletproof until you actually look at how human institutions really function.
Right.
The paper brings in Herbert Simon. He's this pioneer in organizational studies, and his concept of bounded rationality.
Bounded rationality.
Yeah. We have this fantasy that a rational organization operates like a supercomputer, surveying every single possible option, running this massive cost-benefit analysis, and selecting the ultimate optimal choice.
Like it's a giant math equation.
Exactly. But Simon proved decades ago that this is pure fiction. Organizations operate in reality.
Which is messy.
Very messy. They operate in environments filled with ambiguity, constantly contested goals, and, well, fundamentally incomplete information. Because of that, they don't actually optimize, they satisfy.
Satisfy. So meaning they look for a solution that is acceptable, something that meets the necessary threshold, rather than endlessly hunting for some theoretical state of perfection.
Exactly. That is how work actually gets done. The text also introduces the the garbage can model.
Okay, that is a great name for a theory.
Isn't it? It was developed by researchers March, Cohen, and Olson. And it's this brilliant framework suggesting that organizations frequently don't even know what their goals are until they start working.
Wait, really?
Yeah. In this model, problems, solutions, and decision makers basically swirl around somewhat independently, kind of like items in a garbage can.
Oh, I see.
You might have a team with a brilliant solution just waiting around for a problem to attach it to. Goals are constructed, revised, and fiercely argued over through the messy act of actually doing the work.
But wait, I have to push back here a little bit.
Go for it.
Because you just described a totally chaotic environment where human inconsistency basically reigns supreme.
Yeah.
Like if a judge or a loan officer is having a bad day or, didn't get enough sleep, they might deny a claim they would have approved yesterday.
It's true.
So shouldn't we desperately want to replace all that messy human satisficing with perfect algorithmic optimization?
Well, if we connect this to the bigger picture, we really have to recognize what true organizational rationality actually demands.
Okay.
In a complex, shifting environment, genuine rationality requires contextual sensitivity.
Right.
It requires interpretive flexibility, knowing when you actually need to reframe a problem entirely rather than just solving the one sitting right in front of you.
Oh, that makes sense.
And it requires value awareness, which is the understanding that a measurable metric is just a stand-in for a value. It's not the value itself.
Yeah.
AI undeniably calculates way faster than humans. But superior calculation simply does not equal a more rational decision when the environment itself is ambiguous.
Which brings us to the real meat of Dr. Westover's research. Since we've established that organizational rationality is this fluid, nuanced process, let's look at what actually happens mechanically when an algorithm enters the chat.
Let's get into it.
The paper identifies this cascading effect of organizational breakdown, and it starts with something called metric displacement.
Right, metric displacement. This occurs when an organization basically stops aiming for its actual authentic goals and starts optimizing for measurable proxies instead.
Like the hospital example we touched on earlier.
Exactly. The paper highlights this massive real-world study by Obermeyer on a widely deployed healthcare algorithm. The authentic goal for the hospital was to identify which patients needed additional medical care. But the engineers building the system needed a quantifiable data point to train the AI on.
So they used what?
They used historical healthcare costs as a proxy for health needs.
Because cost is incredibly easy to measure, right?
Yeah.
Like $1 spent is a super clean data point.
It is remarkably clean data, but it completely ignores systemic reality.
Oh, right.
Historically, due to systemic inequities and access issues, significantly less money was spent on the healthcare of Black patients compared to equally sick white patients.
Oh, wow.
So when the algorithm ingested that historical data, it systematically underestimated the medical needs of Black patients.
That's horrifying.
The proxy metric, predicting who would incur costs, it looked incredibly accurate. It was doing its job perfectly, but the actual organizational objective, identifying who needed medical help, was completely undermined.
So it's like grading a high school creative writing assignment based entirely on the word count.
That's a perfect analogy.
You can hit the metric perfectly.
Yeah.
The system might spit out an A+ because you wrote exactly 5,000 words, but the essay itself could just be a repetitive string of absolute nonsense.
Exact.
And for you listening, if your team has ever found themselves frantically chasing a KPI that actually ends up hurting your core mission, you have experienced metric displacement.
And when AI gets involved, it scales that dynamic exponentially.
Definitely.
And that displacement feeds directly into the next mechanism, which is cognitive compression.
Cognitive compression.
Right. When an AI system starts churning out these highly optimized, metric-driven answers, human workers don't usually challenge it.
They just go along with it.
Yeah, human judgment is systematically narrowed to fit around the AI's default parameters. The human stops looking at the messy reality of the situation and essentially just becomes a rubber stamp for the algorithm's output.
Just because it's faster.
Faster, and it requires way less cognitive load.
So the human judgment just shrinks to fit the digital box.
Yeah.
And as that judgment compresses, we see the third mechanism kick in, which is contextual erasure.
Right.
This is where the AI totally eliminates the situational exceptions that make human systems actually function. The paper cites some really compelling research by Virginia Eubanks on automated welfare systems.
This illustrates the mechanical failure of contextual erasure perfectly. Because in these automated welfare systems, human reality is just often too complex for rigid parameters.
Yeah.
So if an applicant missed an appointment because they were fleeing domestic violence, or if a piece of mail wasn't returned because the person was currently experiencing homelessness.
A human caseworker would absorb that context,
Right.
right? They'd adapt.
Exactly. But the algorithm literally cannot process a narrative exception. It treats those complex human lives simply as system processing errors.
Or just non-compliance flags.
Right. The context is entirely erased just to serve the efficiency of the machine.
Which leads to the final and maybe most dangerous mechanism in this sequence, reflexive capacity atrophy.
Which is quite a mouthful.
It is a very dense academic phrase,
Yeah.
but it basically means the organization loses its collective muscle memory for asking, wait, why are we doing it this way?
It is essentially the death of organizational self-awareness.
Wow.
When an AI system handles all the complex decisions, the daily, messy practice of debating the premises of those decisions just disappears.
Because the machine is doing it all.
Right. The machine operates as this black box, constantly spitting out what to do. And over time, the human workforce simply forgets how to step back and question the foundational logic of the operation. The reflexive muscle literally atrophies from lack of use.
So we have an organization that is optimizing the wrong metrics, rubber stamping the outputs, erasing human context, and totally losing its ability to question itself.
That's a bad combination.
It becomes incredibly fast at processing data,
Yeah.
but completely blind to whether it is actually doing the right thing. But what happens when these incredibly fast, completely irrational decisions hit the actual people on the receiving end? The text points out this creates massive power asymmetries, starting with interpretability erosion.
Right. So think about a traditional bureaucracy, even a deeply flawed, frustrating one.
Yeah.
If a bank denied your loan or a government agency rejected your application, you generally received an explanation. A specific rule was cited. You had a comprehensible account of the decision.
Something you could read.
Exactly. But with algorithmic decision-making, that interpretability completely erodes. An individual is often just handed a numeric score.
Yeah.
Your resume goes into the void, your medical treatment is flagged, and you receive literally no explanation you can actually understand.
You just get a red X on a screen.
Right.
And the paper argues that this creates profound agency compression and dignity effects because you cease to be a person with a narrative and you just become a mere data point.
It's dehumanizing.
It is. The text contrasts this modern reality with Michael Lipsky's classic concept of the street-level bureaucracy.
Yes, the street-level bureaucrat.
Because in the past, you might have to deal with a notoriously grumpy clerk at the DMV or, like, a super strict caseworker. It wasn't always pleasant, but that clerk possessed human discretion.
Right.
They could look across the desk, see your specific situation, and recognize you as a human being facing unique circumstances. But algorithmic classification entirely strips away that human encounter.
And because that human encounter is gone, we see a massive reduction in contestability.
Because how do you fight a red X?
Exactly. Challenging an algorithmic decision requires immense, often completely insurmountable resources. You need deep technical knowledge to understand the system's architecture, you need your own massive data sets to prove it is wrong, and you need institutional leverage.
It's impossible for a normal person.
It is. The text actually details a real-world example of this from the Netherlands, the CIRI program.
Oh, that was an algorithmic system deployed to detect welfare fraud.
Right. Yes. And it became a massive legal battle. It was ultimately struck down by the Dutch courts. The system was generating risk scores and flagging citizens for fraud investigations. But the architecture provided virtually no space for human caseworkers to exercise any contextual judgment.
So if someone had a weird but totally legitimate situation,
the system offered no mechanism to account for it. If it triggered a flag, that was it. And the courts actually ruled it unlawful precisely because it stripped away that necessary human context and made the decisions fundamentally impossible for average citizens to contest.
Okay, but let me play devil's advocate for just a second here.
Go for it.
How is arguing with a computer system fundamentally different from arguing with a stubborn human boss or a rigid bureaucrat? Like, a brick wall is a brick wall. If the outcome is a no, why does the mechanism matter?
Well, what's fascinating here is the underlying paradox of why organizations buy these systems in the first place. They suffer from what the research calls metric fixation. Leadership teams desperately want to appear objective, rigorous, and legitimate to the public or to their shareholders.
So they buy an AI to look perfectly unbiased.
Exactly. They deploy AI to prove they're eliminating human bias, but by making their decision-making processes entirely opaque, incomprehensible, and impossible to contest, they destroy public trust.
Oh, I see.
They actively erode the very institutional legitimacy they just spent millions of dollars trying to buy.
Wow. Okay, so the picture painted here is fairly stark. But we aren't going to just, unplug all the servers and throw our computers into the ocean.
No, of course not.
Because the efficiency gains of artificial intelligence are undeniable. I mean, the ability to screen 10,000 documents instantly is a superpower.
It absolutely is.
So how do we fix the architecture? How do we design systems that harness that computational power without sacrificing the human judgment?
Well, the paper outlines several structural interventions, and it starts with transparent governance that actually has teeth. It highlights Microsoft's AI Ethics Committee as a really good working example. Because this isn't just a group of engineers, it includes ethicists, legal counsel, and community representatives.
A mix of perspectives.
Right. But the critical distinction is their substantive authority. They are not an advisory board that just rubber stamps projects. They possess the actual power to halt a deployment if they determine an algorithm compromises core values or lacks necessary contextual safeguards.
So governance is the structural fix, but there is also this brilliant intervention at the user level regarding how we present the data. The paper discusses judgment sequencing, according to a fascinating study by researchers Green and Chen on how judges interact with algorithmic risk scores.
Oh, this study is so good. It gets right into the mechanics of human psychology and anchoring bias.
Yeah.
When judges were shown the algorithm's risk score before they read the actual details of the case file, they anchored incredibly heavily on the AI's recommendation.
They just trusted the math.
They deferred to the machine's perceived mathematical authority. However, when the sequence was flipped, when the judges were required to read the case file first and only saw the algorithmic score afterward, they made significantly more independent, contextually rich assessments.
That's wild. Just changing the order in which the information is presented physically preserves the space for human judgment.
It makes a huge difference.
And here's where it gets really interesting. It is not just about the sequence of information. It is about how we train the people using the tools.
Right.
The third strategy is algorithmic literacy. The text points to Northwell Health. When they rolled out a new diagnostic AI for their medical staff, they took a completely counterintuitive approach.
What did they do?
They didn't just show the doctors where to click or how to navigate the interface. They explicitly and rigorously taught the staff about the system's limitations.
Oh, what?
Yeah, they taught them the failure modes. They showed the doctors exactly where the AI was statistically likely to be wrong. And paradoxically, by teaching the medical staff how the system fails, it dramatically increased their appropriate use of the tool.
Because they removed the dangerous binary of either, trusting the machine blindly or rejecting it entirely out of fear.
Exactly.
By understanding the boundaries of the tool, the doctors could confidently deploy it where it excelled and then actively override it where it lacked context.
Right.
The paper also points to participatory design as a solution. Like, the city of Amsterdam created an algorithm registry, publicly documenting every AI system used in city services.
Oh, I love that.
But they didn't build it in a vacuum. They designed it with heavy, ongoing input from the residents who are actually affected by these algorithmic decisions. Inviting the public into the design process dramatically increased transparency and trust.
But hold on, when we talk about algorithmic literacy, isn't that just like an academic way of saying we need to give our employees better IT training?
It is a critical distinction to make, actually. Traditional IT training is fundamentally about teaching compliance.
Okay.
It teaches an employee how to use a piece of software exactly as the vendor intended, following the approved steps. Algorithmic literacy is almost the exact opposite.
Really?
Yeah, it teaches an employee when to critically evaluate the tool, it trains them when to doubt the output, and most importantly, it empowers them to override the machine based on their own contextual, situational knowledge.
So it's about skepticism.
Exactly. It's about actively maintaining human skepticism, not just achieving passive compliance.
So fixing the immediate design flaws, sequencing the information correctly, training for skepticism instead of compliance, creating real governance, that is all crucial.
Absolutely.
But Section 5 of Dr. Westover's paper zooms out and asks a much more daunting question.
Okay.
How does an organization maintain its collective wisdom over years or even decades when the AI is doing all the heavy lifting day in and day out?
This brings us to the concept of institutional reflexivity. Organizations must build in mechanisms to routinely and rigorously evaluate their own systems.
Right.
The paper points to IBM, which conducts regular ethics audits through their AI ethics board. Crucially, they involve non-technical staff in these audits.
Bringing in everyday employees.
Exactly. They recognize that the ability to reflexively question an AI system is a core organizational competence that must be practiced. It can't just be a technical chore relegated to the IT department.
To really drive this home, the paper uses this incredible analogy about expertise decay, looking at the aviation industry.
Yes.
Modern commercial pilots rely incredibly heavily on autopilot systems to navigate complex routes.
Sure, for efficiency.
But airlines legally mandate that pilots spend specific amounts of time manually flying the plane. They also require rigorous regular simulator time for emergency scenarios.
Right.
They intentionally force pilots to fly manually because they know the automation will eventually fail, or it'll encounter a situation it just wasn't programmed for. If the human hasn't practiced, they literally won't know what to do.
The muscle memory is gone.
Exactly. The paper argues that organizations must do the exact same thing with their decision-making. They need to purposefully rotate staff into manual, unassisted decision-making roles so their critical thinking expertise doesn't decay.
Because if you fail to maintain that human muscle, you create incredible institutional brittleness.
Brittleness, yeah.
The organization becomes entirely dependent on an automated system, but it lacks the human backup required to even evaluate if the system is still functioning correctly.
It is exactly like using a GPS app to drive around your own city.
Oh, totally.
For the first few months, it feels like a superpower. It routes you around traffic, it's highly efficient. But after a year of blind compliance, you realize you've completely lost your internal mental map of the streets.
You have no idea where you are.
You don't know how neighborhoods connect anymore. If your phone dies, you are literally stranded in your own zip code.
Which raises a really important question about how organizations survive shifting environments.
Yeah?
The text details a famous example from Target Corporation. Years ago, Target developed this highly accurate predictive algorithm that could identify if a customer was pregnant based purely on subtle shifts in their purchasing habits.
Oh, I remember this.
The goal was to send highly targeted marketing materials, and mathematically, the system was brilliant. It perfectly optimized its predictive accuracy.
But the environment they were operating in suddenly changed, right?
Precisely. Public expectations around data privacy and surveillance shifted dramatically. Target faced a massive wave of negative publicity because customers felt the targeted mailers were deeply invasive and, well, creepy.
Yeah, super creepy.
But Target did not solve that crisis by engineering a mathematically better or more accurate algorithm.
Right, they couldn't math their way out of it.
Exactly. They solved it by using human organizational wisdom. They realized they needed to balance their predictive capabilities with customer trust. So they started mixing random items like lawnmowers in with the baby coupon so it didn't look like they were spying.
The algorithm couldn't read the room.
No, it couldn't. Only human beings possess the situational awareness to do that. Keeping humans deeply in the loop is not a sign of technological weakness. It is the ultimate form of organizational resilience.
Wow.
True organizational wisdom means recognizing that AI and human judgment are complements. They're not substitutes.
So to bring this all together, what we've learned from Dr. Westover's research is that artificial intelligence is undeniably a powerful tool for narrow computational tasks. It can process data at scales the human brain cannot even fathom.
Unimaginable scales.
But mistaking that rapid data processing for actual wisdom is a very dangerous category error. It leads to optimizing the wrong metrics, erasing the nuance of human context, and ultimately creating organizations that are fast, brittle, and deeply irrational. So for you, listening right now, here is your takeaway. The next time you are sitting in a strategy meeting and someone suggests letting the new AI handle a complex, ambiguous decision just to save time, you are now equipped to raise your hand and ask one simple question. Are we optimizing a metric, or are we exercising judgment?
Identifying that difference is truly the key to surviving the algorithmic age.
So what does this all mean? We've spent this entire deep dive looking at how individual organizations lose their rationality when they over-rely on these systems. I want to leave you with a final thought to mull over.
Okay.
Dr. Westover's paper focuses on single institutions. But think about the broader market. What happens if every hospital network, Every major commercial bank and every court system in an entire industry buys their decision-making algorithms from the exact same handful of tech vendors.
Oh, wow.
If artificial intelligence systematically narrows human judgment, are we heading toward a future of industry-wide cognitive compression, where an entire sector makes the exact same irrational mistake at the exact same time? It is definitely something to think about the next time you ask that highly efficient line cook to write your 5-star menu.